Today we are on Saxon Math Book 3, Lesson 47, and we're going to be talking about equivalent fractions. So if you are in my class, you have some papers. I don't remember if I've had you cut them out already, but they are uploaded on Teams under Files. In the 3rd grade lesson plan folder, it says fraction circles or fraction manipulatives. You will need those after today's lesson. For watching me, you can just watch me do it, but then you're going to have an activity that you will need the fraction circles for. So they look like this. Here are the halves, and then we also have thirds, fourths, fifths, sixths, and eighths. And so the first thing we're going to do today is kind of play around with these fraction circles to see what pieces make the same size. So I'm going to start with 1/2 here. If I have 1/2, goes right there. Oops. And let's say I take a third. So this is 1/2, this is 1/3. You can see if I line them up there with the third on top of the 1/2, they're not equal. So 1/3 is less than 1/2. Well, if I take another third, can I make them be equal? Let's say I put another third right there. Now you can see that 2/3 is more than or greater than 1/2. So that doesn't work either. The thirds, I can't have any number of thirds and make it equivalent to 1/2. So we'll put the thirds away. Let's take a look at the fourths. So here's 1/4, here's 1/2. If I lay those one right on top of the other, ooh, that's looking promising. 1/4 is less than 1/2. But if I stick another fourth there, it's exactly the same. So 2/4 is equal to 1/2. We say they're equivalent fractions. 1/2 is the same as 2/4. And we can write it like this. All right, well, I also have fifths. So I can put fifths on top of my 1/2 fraction piece. 1/5, not big enough. Maybe 3/5? Let's try it. There's 2. Riker's saying he thinks it needs an 1/8. In any case, 3/5 is too much. So 3/5 is greater than 1/2. I can't make those into equivalent fractions. What about 6? Here's 1/6 compared to 1/2. And then I can stick another 6 up there. This will be easier when you guys do it because you'll just do it flat on the table. You won't have to hold it up for a camera. There's 3/6. Hey, look at that. It's a perfect fit. 3/6 is also equal to 1/2. So I already wrote that 2/4 is equal to 1/2. I can just stick another equal sign here and say 3/6 is also equal to 1/2. All right, here's my half. What about eighths? Eighths are the last fraction piece that we have in our manipulatives, but I can hold up 1/8. This is going to be difficult because it'll take a few, and I only have so many fingers. Let's see. There, I can hold those two together like that. That's 2/8. Oh, I think we might be noticing something here. There's 3/8. Riker, can you help me out by holding up the 4th 8 there? Put it right up there. Do they fit? Yes, 4/8 is also equal to 1/2. Okay, let's go ahead and put this down and we'll write that up on the board as well. Thank you. So I'm noticing a pattern here, and we're going to talk about this more in future lessons, but I just want you to notice something about the denominators of each of these fractions that are equivalent to 1/2.
I know.
What do you notice, Riker?
4 plus 4 equals 8. 3
Oh.
plus 2 equals 4.
So he noticed something. It wasn't even what I was trying to lead you to, but again, we're going to talk about this in future lessons. He said 4 plus 4 equals 8, 3 plus 3 equals 6, 2 plus 2 equals 4. That is definitely a pattern having to do with the 1/2 fractions or any fraction equivalent to 1/2. The other thing that I wanted you to notice was look at the denominators only. 2, 4, 6, 8. What is true about those denominators? They are counting by twos. What kind of numbers are they? Excuse my dogs.
Even.
They are even numbers. The thirds didn't work. We couldn't have thirds equal to 1/2. The fifths didn't work. We couldn't have fifths equal to 1/2. So fractions equivalent to 1/2 always have a denominator with an even number. So that's just kind of a pattern that you can notice. So we also might want to find fractions equivalent to 1/3. Notice I'm picking the bigger pieces to start with. We could also take the little pieces and say, oh, how many of these? Can I find a bigger fraction that's equal to 2/8? And we will in a little bit. But for now, I'm just starting with the bigger piece and saying, can we find little fractions that we can add up to equal 1/3? Well, since I have the eighths out.
6.
Oh, Riker's saying we should use 6. Well, here's eighths. 1/8, 2/8. Yeah, it doesn't look like that's going to work there. There's not enough left for 3/8 to equal 1/3. So Riker said, let's try 6. Let's do that. Here's 1/6 and 2/6. There we go. 2/6 is equal to 1/3. So we can write that up here. Okay, what about 1/4? I would consider this kind of my last big piece. The rest of them, they just get tinier and tinier. Here's 1/4. Can we use 6 to equal 1/4?
No.
No, doesn't look like that's going to work. Oh, how about eighths? So here is 1/8 and 2/8. And hey, that equals 1/4 as well. Okay, here's my fifths. Do you think we can add up eighths or 6 to equal 1/5? Here's 1/8. No, that's not going to work. You can tell that it's not going to work because if you split this, in order to be a fraction, we'd have to split it in half, right? Or in equal thirds or something. And so if I put my eighth over top, I can see that this piece is bigger than this piece, which means not a fraction, because in a fraction, all of our pieces are the same size, same shape and size. We call that congruent. All right, so these are my little fractions. We add these up to equal the bigger fractions. We didn't find anything equivalent to 1/5, not out of the fractions we have. So it exists, but we're not going to talk about that in today's lesson, okay? So in your books on page 255, there is an activity, and I want you to use these fractions. You can print them out from the files on Teams to do the activity in that book after the lesson. I have a couple more examples I want to do with you, and then you'll be on your own to practice playing with these fractions and doing the activity. Okay, so let's get rid of these. And for this example, we have a picture. In fact, we're going to look at the fifths right now. So let's say 3 of these are colored in. So what fraction would this be? Go ahead, Riker. 3/5. We have 3 colored in out of 5 equal pieces. So that's 3/5. And we want to make it a bigger denominator. We want to make an equivalent fraction. It could be a bigger denominator, it could be smaller. In this case, we're going to make a bigger denominator, which a bigger denominator means we're going to take the same shape and we're going to break it into more equal pieces. So if I have my same rectangle here, it was fifths, and I want to break it into more equal pieces. So what could I do? How could I break each of these into smaller pieces? I could break them in half, right? Okay, so I'm going to split it right down the middle.
That makes sense.
Now I have 10 congruent pieces because I took 5 and I just split them in half. So I can put a 10 in the denominator. Now, these are supposed to be equivalent fractions, which means I have to color in the same amount here that I have colored in over there. So that was going to be all of this bottom fifth, all of this one, and all of this one. So now, how many pieces are colored in? Do I still only have 3 pieces colored in?
No.
How many pieces are colored in now?
6/10.
I have 6 because I took the 3 that were already colored in and I split them in half. So 3/5 is equal to 6/10. So let me tell you what you might see on a test. You might have a question that says, show a fraction that's equivalent to 3/5. Draw a picture to show that they are equivalent. So what they want is 2 pictures in that case. So let's say this was the question. They gave you the 3/5. They probably wouldn't give you the picture. They'd just say, draw a fraction equivalent to 3/5. So you would have to write 3/5 is equal to, and then our equivalent fraction in this case is 6/10. You would also have to draw both of these pictures. Here's what I often see that is not considered correct on that question. Oftentimes I'll have kids that go, okay, here is 3/5, and they'll start out drawing the 3/5, but they won't want to draw the second rectangle. So instead they'll just say, I started with 3/5, right? I know this. I split it into tenths. So now I'm going to say 3/5 is equal to 6/10, but they only have one picture. They're only showing me the 6/10. And what I need to see is both fractions to show that you have 2 of the same shape. One is split into fifths, one is split into tenths, and they're equivalent fractions. Because I don't see you drawing the picture. I don't see you in your mind going from fifths to tenths. So you've got to have both pictures to show me the whole process of finding the equivalent fractions, okay? That'll be on your tests coming up probably in the next 2 weeks. All right, the next example. Oh, I can get rid of this too. The next example says the first rectangle has 3 equal parts. So let's draw a rectangle. It has 3 equal parts. We see that 2 of the parts are shaded. So 2/3 of the figure is shaded. So they even tell you this is 2/3. The second rectangle has 6 equal parts, and if you're looking in your book, you can see this. It looks just like that, and there's an equal sign between them. And then it has a question mark over top of a 6, because they told us it has 6 equal parts, so that's going to be our denominator. It says, copy or trace the rectangles on your paper, then shade the second rectangle to match the shaded part of the first rectangle. Study the rectangles to help you complete the equation. So they want you to copy all of this. If this were a homework problem, you would copy all of this into your notebook, and then you have to shade the same amount over here that we have shaded over here. So I'm gonna color in the whole bottom third, and then the whole middle third. And then it says, study the rectangles to figure out what number goes in the numerator of our second fraction. Well, 1, 2, 3, 4. So that's going to be 4/6 is equal to 2/3. All right, ladies and gentlemen, that's the end of our video portion of the lesson today. I do still want you to do the fraction activity that is on page 255. You'll need your fraction manipulatives for that. If you are not in my in-person class and you've just found this video online, you can create your own fraction circles. Just cut, let's see, we have 1, 2, 3, 4, 5, 6, 7. I thought there were 8. 6. Anyway, you're gonna cut several of the same size circles out. You'll split one, there's 6. You'll split one into halves. You'll split one into thirds, fourths, fifths, 6, and 8ths for a total of 6 circles broken into different fractions. And then your student 2 can do an activity where they are comparing different fraction pieces, trying to find equivalent fractions. I hope you have a wonderful day, and we will see you again soon.